Hello, in this video we're going to talk about how to solve a quadratic using the zero product method, or what you've heard me call ZPP. Now, I will say the zero product property plays a very small role in the overall scheme of things, but you will see language saying, oh, solve this, or what are the solutions? But what we need to know, and the reason why the zero product property gets brought into all of this, is that when we multiply two things together and their product is zero, that means one of those things is zero. What that means in language you understand is that when I multiply anything by zero, it's zero. So as I look at this equation I have in front of me, I have two things multiplied together. Their product, their answer, is zero. And what this means is one of those two things is zero. Now, where this starts getting tied into all the quadratic work we did previously is that what we want to really do is solve this quadratic equation. I want to know when my graph crosses the x-axis. So in our last unit, we were graphing a quadratic. We would find the vertex, we'd find other points, and we would just reflect them. You see me just doing a rough draft on the right-hand side here. We don't actually need to use that table and that plugging and chugging method, because what we can do is we can solve and find out where our graph crosses the x-axis. We really care about this outside of math, and the reason why quadratics are so important is because we are solving for when the value of my function is zero. Now, this is important because if you have anything flying through the air, it is following that parabola that we've been graphing. So we talk about a ball or anything being launched. We're finding out where it's launched from and where it's going to land. So what we want to do is we want to find the numbers that make my equation equal to zero. And how I do that is I'm going to split my equation into two pieces. The two things that were being multiplied together, and I am going to set both of them equal to zero. This is what ZPP is saying. It says, hey, two things multiplied zero. Let's find out where they're actually equal to zero. After this, we go from second semester algebra level to like seventh grade. We are going to solve two basic equations. The way we solve the equations is the way we always have done, is with our opposites. Now, off to the side here, you are going to see me talk about our operations and their inverses. Just so that we're all on the same page, the inverse of addition is subtraction, the inverse of subtraction is addition, and multiplication and division are inverses. And what that means is I can use this opposite to start solving my equation. So for this purple equation over here, I see addition. So I'm going to use the inverse operation, which is subtraction. I'm going to subtract 12 from both sides of the equation. I'm going to divide both sides of the equation by 3. I get negative 4. Over here, I see subtraction, so I add to both sides. Okay. Now, some of the words that are going to get used, x is negative 4 and x is 4 are my solutions. They are also my x-intercepts. Now, those two words have different contexts. Solution is like, hey, I'm just solving it, or I'm just looking for those answers that we just found, the 4 and negative 4. X-intercepts imply graphing. As we start assessing this or testing over this, yeah, you need to know that I'm going to say what are the solutions, and I also need you to know that these things are also x-intercepts. So as we're looking at this, again, the big idea here is that we can solve a quadratic equation. This is called using the zero product property, or ZPP. And when I do that, what I am finding is where my graph crosses the x-axis, or what my x-intercepts are. Now, as I'm solving this, I can get positive numbers, negative numbers, fractions, decimals. It's all the same. And the other thing that you can notice is that I can plug both of these numbers into my equation, and it's going to equal 0. Now, I'm going to erase all this so I have room to show you this. If I plug, for example, -4 into my equation, I would have 3 times -4 plus 12 times -4 minus 4. Then, as I start calculating what's happening, notice I take 3 times -4, that's -12. -12 plus 12 is 0. 0 times -8 is 0. I can plug my other answer I found in, +4. So I have 3 times 4 plus 12 and 4 minus 4. I could show all this work on the left-hand side, but I'm not going to. Because 4 minus 4 is 0. It doesn't matter what 3 times 4 plus 12 is, because it's being multiplied by 0. Now, you are not required to do what I just did on the right-hand side, where I'm showing my work, where I'm proving it. You need to just be able to do this piece here and show that work. Everything else I'm doing is just trying to give more context and explain, hey, what is happening when we solve. I have one more example, and then every other example that we are going to do with this, namely factoring and then solving, this is just the solving portion of this. Once again, I have an equation. I have two things being multiplied together. Once again, I would set both those pieces equal to 0. I would solve both those equations. Now, it doesn't matter what your equations look like. And I have two pieces multiplied together. I split them. I found my roots. I can say that, hey, when you have something that looks like this, right, one of your roots is always going to be 0. One of your solutions is always going to be 0. The reason for that is, going back to what I just talked about, I have 9 times, or some number times, a variable. The second I put 0 in for my variable, I have a number times 0, which the whole overarching idea for this is anything times 0 is 0. And that something times 0 is 0 just kind of cascades through the problem. Now, as you're doing this, do not get held up on, oh, hey, it's supposed to look a certain way. After you've done enough practice, yes, you will pick up on this. Your job is just to, every single time, set your two equations equal to 0 and solve those two equations. In this video, I've probably over-explained things, especially talking about how these are your x-intercepts or solutions, but really this is the foundation for what is new in this unit. And as you do more practice with this, as we work with them more, you'll see how those pieces get built up. Anyway, as you are practicing more from the things we've done in class, please reach out with any questions that you have. And again, this is how we would solve a quadratic equation using ZPP.